quick overview of stuttering on the LHY Studios M2 Nano board, why it happens and what you can do to prevent it. First, a crash course on the work cycle of the M2 Nano. This here is the CH341 Universal USB chip. And over here we have a 40-year-old processor. It came out in 1980 with little bits of firmware. Over here we have stepper motor chips and the other stepper motor chip and the Schmidt trigger to make the laser fire in a snappier fashion. The board doesn't have any memory, and the bytecode it sends doesn't do anything other than changing the states on the hardware. So the R and L commands flip the direction in the A4988 stepper chip, and the T and B commands flip them on the other chip. So the D and U commands turn the laser on and off, and that's basically the entire thing, with some odds and ends that you could check on the Meerkat wiki. The amount of memory is about 128 bytes stored on the CPU because it doesn't have a separate memory chip. The data streaming protocol has the chip mark itself busy when it can't accept new packets of information, and when it has room in the buffer, it flags itself as okay and the new data can be sent. The stutter happens when the buffer underflows, when the amount of commands left in it to execute is 0. Now the commands to flip the states on and off in the chips are basically instant. The only thing that takes time is going distances, and these are encoded in lowercase characters, and they measure a distance in 1/1000th of an inch. A is 1, B is 2, etc. These distances are the only thing that really matter with regard to time. So if you have some LHY micro GL code that looks like this, the Z commands here are movement by 255 units, and the 111 and 114 numbers are distances of that size up to 255. This code should never stutter while we're traveling. It's 1,641 units, in which case is 1.6 inches, and it took 9 bytes to move the laser the 1.6 inches. So this command will have plenty of time to request additional data, since if we're traveling at 200 millimeters a second, the first laser down in 1.6 inches will take 200 milliseconds. And there's like 4 of these stored in the packet, so we'll have plenty of time. Okay, I'm gonna make Meerkat produce really inefficient or like low energy data density. Okay, let's do rect, start at 0, 0. We're going to go 5 inches by 10 centimeters. We now have this rectangle here. Now I'm going to say fill that gray. Now, if we check the fill, you can tell that this is 128, 128, 128 gray. It is as solidly between black and white as you can get, so it'll go one on, one off when it's rastering. So let's go ahead and let's go refresh classification, and now it exists here. Start the job, execute, starting the job. Alright, now we load up the controller, and you can see right here it's going on, off, on, off, on, off, on, off constantly. When we look at the log, we get this. This is 1 step each time. We now have the opposite extreme. In a 30 byte packet, we will travel 15 mils, 1/1000th of an inch. At 200 milliseconds, the packet will complete in 1.9 milliseconds to complete all the commands in that packet. It doesn't flag itself as ready to accept new packets, except in little gasps. And the protocol takes a bit of back and forth latency with the USB. The entire buffer of all of our data can be completed in about 8 milliseconds before additional packets are required to stop it from stuttering. However, if we're going at 50 millimeters a second, we have 32 milliseconds before the buffer is empty. This is why slowing down will reduce stuttering. Here we have some Whisperer LHY micro GL code, and unlike some of the other examples, you'll notice that it includes some redundancies for the capital T and capital B commands for each movement it makes. So rather than write it more compactly like it's written in the original Chinese software in Meerkat, it restates the directional flags. So let's go over a quick example. Here we have TBU, TBD, TBU, TB. This can actually be written as just BU, BD, BU, B. So long as T is originally set somewhere before we started, it will remain flagged on the stepper chip, and we don't have to repeat this. Whisperer, however, will always repeat this, and it makes it about 33% less compact. So if we go back to our worst case scenario, but we also restate the direction flags for each new move command, rather than 2 bytes per 1-step command, we're going to do 3 bytes per each 1-step command, which gives us 10 rather than 15 commands for our 30-byte packets. If we go back to an example where we're doing 200 millimeters a second, the original 2-byte commands would have taken 1.9 milliseconds to finish the packet and do the entire buffer in 8. However, here with the less dense restating, we do 1.27 milliseconds to finish the packet and 5.4 milliseconds to finish off the entire buffer. So we both are sending fewer commands into the buffer, and the buffer completes these fewer commands more quickly. This is why Whisperer will stutter significantly before Meerkat does. Scorch did try to fix this at one point, but ended up nuking the version. Without storing the flags of the chip states, it's really easy to fail to restate the directional flags when you switch from M diagonal movements into orthogonal movements, because you need to resend the directional flag to switch it from diagonal movement into orthogonal movement, which requires restating the direction there, but only in that one special case, and failing to do it caused the bugs in the nuked version there. There's another issue that gets some attention in Whisperer, is the USB drops. This can often happen even without any connection problems at all, because the read cycle cannot happen when the laser head is in a single execution cycle. If you do a cut purely involving x-axis or y-axis, for example this is a single move in the T direction at about 1024 mils, which is just over an inch, or about 26 millimeters. However, the timeout in Whisperer is set for 200 milliseconds. So unless the speed is greater than 104 millimeters a second, this will cause a USB timeout. Since, well, in a single command move, the USB device won't return any packets. At 26 millimeters per second, the command would take an entire second, during which the device would appear unresponsive. This is largely what's responsible for the USB timeouts in Whisperer. However, it is actually a problem with the M2 Nano board, since it violates best practices for USB, which says that you should give a reply within 250 milliseconds or so. In Meerkat, the timeouts are set long enough that this isn't a problem. This basically should explain the M2 Nano protocol and why it results in stuttering. There's a few mitigation strategies. Most of these are going to follow either one or two things. One, slow down the laser head so it takes longer to complete the commands in the command buffer, or B, changing the commands in the buffer so it takes longer for them to complete. Compare this fairly quintessential half on, half off code where it's going UA, DA, etc. So it's moving one unit. Compare this to the alternative form where we move, say, 2 units. This will take twice as long to complete and therefore will stutter at twice the speed. However, both codes are still half on, half off and should result in a fairly robust gray. Now, to see how we might do this in practice, here's the gray rectangle that we created before. Now what I'm going to do is I'm going to change the raster step to 2. So it'll be 2 steps on, 2 steps off. And then I will change the, I will make this a raster image, which will change the image in here into a proper raster image. I no longer need this. So this is just an image of a gray rectangle. And then I go to image dither to 1 bit. Now this should actually be an image dithered to 1 bit set at 2 steps per every step. So when we say start job, it'll give us the green light, and then this will be moving at UB, DB. So every time it'll move 2 instead of 1. So this will only start stuttering at twice the speed. So if it starts stuttering at like 140, this would stutter well at about 300-ish. There are some ideas for moving a pixel around by a maximum of 1 move to make the code more compact or allow PPI to create patterns, but these wouldn't be out before 0.7.0. I apologize if this is a bit advanced, but thank you for watching.